All right, here's the third lesson of our Introduction to Calculus. Still taking a look at the equations of lines, but in this case we're now dealing with parallel and perpendicular lines. So if I wanted the equation of a parallel line to this line, keep in mind parallel lines just mean that they have the same slope. And so if I take this equation and get y by itself, so I'm going to subtract that 9x over to the right, which would put me right here. Divide everything by -5. I'm going to get -9/5, which of course will be, -9 over -5, which will be positive. And then -4/5 at the end. So you can see right here a y-intercept of -4/5, a slope of 9/5 if we deal with that double negative. So just knowing that their lines are parallel means I know my slope is the same as that slope of 9/5. And so we're right back into what we did in our last lesson with point slope, just plugging into that formula. So biggie on this one is just to recognize that parallel lines have the same slope, so we're using that idea to get the slope of our line. Knowing that it passes through that point, we can plug into our point slope formula. So we're going to do y minus our y coordinate equals our slope, x minus the x coordinate. So we're going to start by just doing a little distribution here on the right side. So 9/5 x, and 5 goes into 10 twice, times 9 is 18, and then if I add the 3 over, and we got the equation of our line. Right, remember, we always like to end, if we're writing the equation of a line, we always leave it in slope-intercept form unless the directions tell us otherwise. Going on to our second example. So short notes on this one, just 2 examples, but perpendicular lines. Just remember on these guys, they have opposite reciprocal slopes. We can see that the slope of this line is 2, which must mean that the slope of our line would be the opposite reciprocal slope to that. So I'm going to flip the fraction to become 1/2, as well as change the sign to a negative. So again, now at this point, it's right back into the last problem. We got our point, we got our slope. We're going to throw this into our point slope formula. So y minus the y coordinate equals our slope, x minus the x coordinate. And as always, we're just going to work to get y by itself. Start by distributing that -1/2 on the right. And there's just going to be some cases like this one where you're going to have to go back to the use of common denominators and things like that in order to simplify. So if I want to add 2 over to the right, so on this right side I'm going to be doing 3/2 plus 2. I'm just going to do that off to the side here. So as I add 2, or if it helps, you can think of it as adding 2 over 1. Remember, I need common denominators, so in this case my common denominator would be 2. Which means I get to leave the first guy alone. And the thought is always, what would I multiply times this in order to get this? And you can see that I had to multiply the bottom times 2 in order to get this right here, which means I also have to multiply the top by 2. So we're creating our common denominator, and you can always see that you did it right by just sort of working backwards. I can see that 4/2 is the same as 2/1, so I know that I did it right. Now that they have common denominators, when I add those together, I can see it'll be 7/2. So to finish things off, as I added 2 to this number, we're coming up with 7/2 as our y-intercept. And that would be the equation of our line. So again, just keep in mind the idea of parallel and perpendicular slopes and what that would look like. So with a slope of 2, flip that, change the sign, and you got your perpendicular slope.